In this lesson, we introduce direct current circuits. Here are your objectives. Now first, a circuit is a closed loop around which current can flow. And circuits consist of several components. A source of electrical energy, like a cell, a battery, or a generator. One or more loads that are going to convert that energy into other forms, like resistors, lamps, electric motors, etc. And connecting pathways, which are typically wires. I said that the load is going to convert electrical energy, which is a form of potential energy, into some other form of energy. For example, it might be mechanical energy if the load is an electric motor. It might be heat or light in the case of a lamp. It could be sound in the case of a loudspeaker. So the load converts the electric energy into some other form of energy. Well, we also need something to provide that energy to the circuit in the first place. So we need a power source, and that's going to give electrical energy into the circuit. And it's getting that because it's converting some other form of energy. For example, if it's a generator, it's taking the mechanical energy of the rotation of the generator and turning that into electrical energy. Or if it's a cell or a battery, it's taking the chemical energy stored in the cell or battery and converting that into electric energy, providing that to the circuit, and then the load is doing the reverse. Now we have a special name for these kinds of things like generators, cells, or batteries. We call them sources of EMF. And EMF is a funny term that stands for electromotive force, and it's a historical term that's not actually correct. So what electromotive force is really referring to is the potential difference provided by the source of energy. For example, if you're talking about a 9-volt cell or a 9-volt battery, this 9 volts is the potential difference provided by the cell, and that's actually what we would call the EMF. So electromotive force is a kind of incorrect term because it's not a force at all, it's a potential difference. We use EMF, which we give the symbol epsilon to represent the potential difference provided by the source of energy in the circuit. And because it's a potential difference, it's measured in volts, not in newtons like it sounds like it should be when we call it electromotive force. It's not a force, it's a potential difference measured in volts. Over here on the right, I have some symbols from the IB data booklet. These are the symbols that you'll see in circuit diagrams. Let's take a look here over at a cell. When we draw a cell like this longer terminal is the positive terminal, and the shorter one is the negative. So the conventional current is moving out from the positive terminal around the circuit and back into the negative, while the electronic current is moving in the opposite direction. A battery is just 2 or more cells connected in series or in parallel, so this is a battery. A resistor looks like this over here, and a lamp looks like that. We'll see these as we learn more and more about circuits. Lastly, let's define 2 different kinds of circuits. In a direct current circuit, electrons flow in one direction. An example of a direct current circuit is a circuit with a battery or a cell in it, and the electrons are going to flow from the negative terminal of the cell round the circuit and back into the positive terminal. The conventional current flows in the opposite direction. So the electrons are flowing in one direction in a direct current circuit. In contrast, in an alternating current circuit, like the circuits that you get when you plug something into the wall in your house, electrons are flowing back and forth. They're not actually just flowing in one direction. And that's because the generator that is generating that current has terminals that are swapping back and forth between positive and negative. So while in a direct current circuit the electrons are flowing in one direction all the time, in contrast in an alternating current circuit the electrons are flowing back and forth. So that's an introduction to circuits.